Okay, so we're going to talk about velocity first. So just to refresh you, velocity is basically how fast you're moving. So it is displacement divided by time. So it's your change in position divided by the time it takes you to move positions. And then if you'll remember, we also have speed, which is the distance divided by the time. So if you remember, your speed and velocity differ in the fact that speed is the distance divided by the time, and velocity is displacement over time. So usually speed and velocity will be the same thing if they're going in a straight line. But speed, if you also remember, has no direction because it's not a vector, it's a scalar. Velocity will have a direction. So it's just important to keep that distinction in your mind. Okay, so now we're going to look at tangential velocity, or VT. So you'll sometimes see a little v, or the v with a little t like that. That's tangential velocity. So this is the velocity in a circle. That's going to be how fast the object is moving along an imaginary line that's drawn tangent to the circular path. Okay, so let's look at that. Well, here's our circle. We have an object that's moving in a circle like this. It's moving in this direction. Well, if we look at this point right here, and I draw the tangent line along that point, so that's just the line right next to it. Because since it's not moving in a circle, or not moving in a straight line, and it's curved, I would have to look at the tangent line. So that tangent line is basically the line that's drawn right next to a given point on a curve. So we have our tangent line right here. Okay, so we can see that that object at that point is moving in this direction. If I look at this point, though, this is my tangent line. The object is moving in this direction. So along the circle, at each point, if I draw the tangent line, there's a different direction in the velocity. So your tangential velocity will depend on the distance from the object to the center of the circular path. So velocity always depends on the distance. So if we're looking at a circle, we're going to measure the distance from the center of the circle. That's also called the radius. So when you have something that's moving in a circle like this, so let's say that we have a racetrack, and somebody is traveling in this direction along the racetrack, so along this direction, and they are moving with a speed of 50 meters per second. Well, along this circle, the direction will be constantly changing. Since the direction is constantly changing, the velocity is changing as well. But if my speed stays the same, so remember, speed is basically just the number, so 50 meters per second. If it stays 50 meters per second in this entire circular path, the speed is held constant. So if it's held constant in a circular motion, it's described as uniform circular motion, just like we have uniform accelerated motion. So if speed is constant in a circle, it's called uniform circular motion. All right, so velocity is still going to be distance divided by time. It's just because it's in a circle, we have to account for the distance of the circle. So your VT, remember that's just your tangential velocity right there, is equal to 2 pi r. This is the circumference of the circle. That is the distance of the circular path, divided by something we call the period. So big T is the period, and that's the amount of time it takes to complete one circle or one revolution. So little r will be the radius, big T is the period, so it's basically still time, and then pi will be our 3.14. All right, so let's do a problem really quick. Okay, so a plane makes a complete circle with a radius of 3,622 meters in 2.1 minutes. What is the speed of that plane? So because we're moving in a circular path, it says that the plane moves in a complete circle. We know we're looking at circular motion, and it's asking for the speed, so it's really asking for the tangential velocity here. So here it says speed, we're still solving for VT here. Okay, so VT is equal to 2 pi r divided by the period. Okay, so now let's translate the problem. So plane makes a complete circle with a radius of 3,622 meters. So that is our distance, and it even says it's the radius. So the radius is equal to 3,622 meters. And it does that in 2.1 minutes. So that's the time it takes to go around that circle. That will be our period. So that's a big T. So 2.1 minutes. All right, so now I'm looking at this. I'm looking for speed. So this is what I'm looking for. And I know a lot of you want to skip this step where you pull out the information, but you really need to be doing this step. You really need to be doing this. All right, so we're looking for VT. We have R, we know what pi is, and we have T. So we can just plug it in at this point. However, I have meters and I have minutes. If I solve for it now, I'm going to get meters per minute. And I really wanted to have it in metric units, so let's put that into seconds. So I'm solving for seconds, so seconds will go on the top, minutes will go on the bottom. 1 minute is equal to 60 seconds. So 2.1 times 60 should give me 126 seconds. It's not 130, it's 126. All right, so now we can plug it into the problem. So VT is unknown. 2 pi r. R is 3,622 divided by my T, which is 126 seconds. So VT here, so I'm going to multiply everything out. So 2 times 3.14, that's fine. If you want to use the pi button, that's also fine. So multiply it out. I get this. Divided by 126. And I will get VT is equal to 180.5 meters per second. Do not forget the unit here. If you look right here, our radius is in meters, our time is in seconds, so it should just be meters per second. All right, so now that we've talked about speed, let's talk about the acceleration. So because we have a velocity that is constantly changing, because our direction is constantly changing in a circle, we have acceleration. We know that it has to be accelerating because the definition of acceleration is the change in velocity in respect to time. So we have to have acceleration if we're moving in a circle, even if the speed stays the same. So even if the number does not change, the direction will still be changing as it moves in a circle. Okay, so this is called the centripetal acceleration, and it's always going to be directed towards the center of the circle. All right, so our centripetal acceleration is equal to our tangential velocity squared divided by our radius of the circular path. And that little c right there, that little c is for centripetal. So when you see the little c, it's just talking about centripetal. So the little t, remember, is tangential. So these are all terms that imply or tell us that we're moving in a circle. so centripetal acceleration is always going to be directed towards the center of the circle. Centripetal means center seeking. So it's always going to be directed towards the center of the circle. All right, so let's look at this video really quick. Or we will not look at the video. Okay, so when we're moving in a circle, like this, and you're looking at your vectors, you will always have the vector for acceleration pointed towards the center. So at every single point, the acceleration will be pointed towards the center because it's center seeking, it's centripetal acceleration. Okay, so there's a difference between tangential acceleration and centripetal acceleration. You still are moving in a circle for tangential acceleration, but centripetal acceleration will result from a change in direction. That's because you are looking at velocity, and the velocity is changing because the direction is changing. Well, tangential acceleration involves a change in speed as well. So you have to think about if you're driving around in a car. So if you're driving in a car and you're going around a curve, okay, so let's say that you're getting off the highway. So when you're doing that, the speed limit changes as you're getting off that highway on the ramp. They want you to decrease your speed because otherwise, as you go on around the circle, and if you're going 80 miles an hour or 100 miles an hour, you're going to have a problem because the friction may not be able to keep you on the road. So as you move in a circle, hopefully you're slowing down. So that means that you might have been going 50 meters per second, and gosh, that's really fast. But around the curve, hopefully you slow down to a reasonable speed around that curve. So maybe let's say 10 meters per second. Something that's more reasonable, and I think it even should be a little bit less than that. So as you move around that curve, your speed should be changing. However, since you're moving in a curve or moving in a circular path, you should also be changing your direction. So that is tangential acceleration. Centripetal acceleration just results from the change in direction. So tangential acceleration, you'll have a change in speed and direction. Okay, so since we have acceleration, we have a force. So anytime that you have acceleration, you have a net force. So if there is centripetal acceleration, you have a net force, and we call that centripetal force. However, this is not a new force. This is not a new force. It deals with all the other forces we've been dealing with. It's just now we're giving it a new term because we're learning about circular motion. But centripetal force is not necessarily new. So if we solve for force with force is equal to mass times acceleration, we still find the force the same way. Okay, so the net force, the centripetal force, is the net force that accelerates an object towards the center of the circle. So it's going to be the force that keeps that object moving in the circle. Okay, so if I have a mass and I twirl it around in a circle, so I have something on a circle, I'm twirling it around, and there's some mass at the end of the string. The centripetal force is going to be provided by the tension in the string or the rope. That is what causes your centripetal force. So this is still a force that we've talked about before. It's not new. So if I have a car and it rounds around, it's going around a corner, the centripetal force is going to be provided by the friction. The friction is going to be what causes that centripetal force and keeps the car moving in a circle. Okay, and then if we have something that's orbiting, well, if we have something that's orbiting, your centripetal force is caused by gravity. So if we have a satellite out here, it's going to keep moving in a circular path because it's attracted to Earth. So it has gravity that's being applied to it. So really, our centripetal force can be caused by tension. It can be caused by friction. And then it could also be caused by gravity. So right here, our tension, if we have something that's being swung around in a circle, like a wrecking ball, the tension causes that circular motion. If I have two surfaces in contact with each other, like a car on a road, the friction is what causes the car to stay in a circular motion. And then if I have something that's orbiting, gravity is what causes the object to stay in a circular motion. Okay, so in order to get centripetal force, you're just going to take the mass and you're going to multiply it by the acceleration. Remember the little c, that's just centripetal. That's what it means. So what you'll see sometimes is substitution. So if you don't have AC, well, let's see. You know that AC, AC is equal to VT squared divided by my radius. I know that's what it equals. So I could also substitute in this because this is equal to AC. So I could have centripetal force is equal to the mass times VT squared divided by the radius. That's really the same thing. And if it makes you feel more comfortable and you have enough information, of course, you can go ahead and solve for the AC first, which is, you know, a lot of students feel more comfortable doing that. As long as you have enough information, you can do that. So if you substitute in AC, you get this equation. This equation is the same thing as this. It's just rewritten a little bit. Then if we don't have VT, well, you know that VT is equal to 2 pi r divided by my period. So I could put that in there and then get this. So that's our VT. So if I don't have that, I'm going to square it, and then that's how you get this 4 pi r squared here, down here. So this is just a simple method of substitution. All of these equations give you the same thing. They are the same thing, really. But you could also just go and solve for the tangential velocity, solve for the AC if it makes you feel more comfortable. If you have enough information, of course. Okay, so I have a 0.5 kilogram mass, and it's whirled in a circle with a radius of 0.2 meters at 2.3 meters per second. I want the centripetal force acting on the mass. So I know centripetal force is equal to mass times centripetal acceleration. So let's go ahead and write down what we have in this problem. I have a mass of 0.50 kilograms. It's whirled in a circle with a radius of 0.2 meters. And it moves at a speed of 2.3 meters per second. So I know that's my VT. And again, please make sure you're doing this step. So I know this is mass. It tells me this is the mass right here. It also has the unit of kilograms, so that's my mass. My radius, well, it tells me that I have a radius of this. Also, I know it's my radius because that's my distance, which has meters on it. And then it's going at 2.3 meters per second, so that is my tangential velocity. I'm moving in a circle, so I give it VT. VT is my variable here. Okay, so now, well, I have mass, but I don't have AC. So the first thing I need to do is actually get AC first. So I know AC is equal to VT squared divided by the radius. So again, you guys should have written these equations down. I don't expect you to memorize them. So please make sure you have written them down. That's where I'm getting this from. So let's solve for the AC first. So AC is equal to VT squared, so 2.3 squared, divided by my radius. So that's AC. I'm going to do 2.3 squared. It gives me 5.29 divided by my radius of 0.2. So my acceleration is 26.45 meters per second squared. Alright, so now I have my AC. Now I can go back and solve for my BC. Because it's asking for the centripetal force. Do not forget what it's asking for, because I'm not done yet. Okay, so the centripetal force is equal to my mass, which is 0.5, multiplied by my acceleration, which I just solved for. Alright, so times 0.5. My force is 13.225 newtons. That's kilograms times meters per second squared, which is the same thing as a newton. Alright, so now I have my centripetal force. Alright, so the honors had something extra to solve for, so let's go back and look at that. Alright, so it says we have a 0.5 kilogram mass that's sitting on a frictionless table, and it's attached to a hanging weight. So basically we have a weight, some weight, sitting on some table, and this is attached to some hanging weight right here. Okay, so this object right here is moving in the circle, and then this one's just kind of hanging there. And I want to know, so I calculated the centripetal force acting on the mass, so that's not any different with this extra piece of information. But then I want you to calculate the mass of the hanging weight. Okay, so I know the mass of the swinging weight, or the one moving in a circle, is 0.5. I need to know the mass of this weight. Okay. So really, when I'm looking at this right here, I know that since it's hanging there, I have a force of gravity pulling it down, so its weight is pulling it down. And then I also know the tension of the string pulling it up will be going up towards the other mass. So I have two forces here. I have the force of tension, and then I also have the force of gravity pulling this mass down. So, I know that my force of tension is really what causes my centripetal acceleration, or my centripetal force. Okay, so anytime I have a mass hanging by a string, the tension is what causes the centripetal force. So this tension right here is equal to my centripetal force. Well, I have that. I know that I have a centripetal force of 13.225. I also know that my force of tension is equal to my force of gravity, because I've got two forces interacting right here on this weight, but the weight is just staying still. It's not moving anywhere. So those are also equal to each other. So I know that my centripetal force is equal to my force of gravity. Okay, so now I can go ahead and substitute in. My centripetal force is caused by my tension. My tension is going to be equal to my weight, so my force of gravity of that hanging mass. So my centripetal force was 13.225. I solved for that earlier. And my force of gravity, well, that's going to be my mass, times the acceleration due to gravity, which is 9.8. So now I have enough information to solve for my mass. So I'm just going to divide both sides by 9.8. All right, so 13.225 divided by 9.8 should be 1.3. 1.3 kilograms. So sometimes you'll have to do this. You'll have to think about the problem and say, okay, well, look at your diagram, look at your free body diagram, and see what forces are really interacting here. Since you know centripetal force is caused by the tension here, it's really the same thing. The centripetal force is going to be equal to your weight, that weight of that hanging object. Otherwise, it wouldn't be able to move in a circle. All right, so let's go move on. All right, so I have a car that's traveling at 14 meters per second. It goes around in an unbanked curve in the road that has a radius of 96 meters. What is the centripetal acceleration? Okay, so first thing, I'm going to translate the problem. So we have a velocity of 14 meters per second, so that's our VT. Because it's traveling in a curve, it's our tangential velocity. And unbanked really just means flat. If it's banked, it's kind of at a tilt. A radius of 96 meters. It says radius right here. All right, and we're looking for the centripetal acceleration. All right, so I know centripetal acceleration is equal to VT squared divided by the radius. VT is 14. I'm going to square that, divide it by 96. You should get 2.04. All right, so now I have my acceleration, but it's not asking for just the acceleration here. It's also asking for the minimum coefficient of friction between the road and the tires. So anytime it talks about coefficient of friction, you know that you're going to be looking at this equation right here, the funky U times the normal force. All right, so we know we're going to be dealing with this equation because that's the only thing that we have that has the coefficient in it. We also know that the force of friction causes the centripetal force because we're on a car, we're driving right here, so force of friction will keep the car moving in a circle. Okay. We also know something else. My normal force on a flat plane or level plane will be equal to the force of gravity. When it's on an incline, it's different. But we're not dealing with an incline here, so makes life a little bit easier. All right, and then also, you know that your force of gravity is equal to the mass times the acceleration due to gravity of 9.8. All right, so let's substitute in. Okay, so we don't have the force of friction, we don't have the centripetal force, but I could go ahead and solve for the centripetal force. Or actually, no, I can't. I can't solve for centripetal force right here. I have the acceleration, but in order to get force, I would have to have the mass. So in this case, I can't just simply solve for centripetal force first. So let's plug in what we do know and see what we're dealing with. So we know our force of friction is equal to the coefficient multiplied by the normal force. And we know that our centripetal force is equal to the mass times acceleration, or centripetal acceleration. Okay, so let's see if we can break this down even more. I don't know the coefficient, but my normal force I know is equal to the force of gravity on a level plane. So my force of gravity is equal to my mass times 9.8. All right, so I know that my mass is still unknown, but my acceleration here, my centripetal acceleration, is 2.04. All right, so when I'm looking at this problem, these things are equal to each other. Mass is on both sides. So since mass is on both sides, I can get rid of it. It's gone. Now I'm looking at something much more manageable. Okay, so now I have the coefficient times 9.8 is equal to 2.04. So now I just divide by 9.8 to solve for the coefficient. And you should remember the coefficient should be a number less than 1. If you get a number that's greater than 1, you've done something wrong. My coefficient is equal to 2.21. And there are no units for the coefficient. It's really just like a proportion. There's no unit. All right, so when you're looking at these problems, a good idea to remember is centripetal force is really, it's either going to be friction, tension, or it's going to be gravity. So when you look at that, then you might be able to have something more workable. It's not as daunting as it seems. All right, so let's move on to another concept you might be familiar with. Centrifugal force. Okay, so if I have a driver and he takes a sharp left turn, the passenger slides to the right of the car and into the door. So I want you to think about this for a second. Think about why that might happen. If we're looking at that word centrifugal, that word means center fleeing. So centripetal means center seeking. Centrifugal means center fleeing. It is an apparent force that causes a revolving and rotating object to move in a straight line. However, it is not that simple. Newton's first law states that an object in motion will stay in motion until force acts on it. That first law right there, that actually deals with something called inertia. Inertia makes you want to move in a straight line. It wants to resist change. So if you're sitting still, inertia makes you want to keep sitting still. If you're moving in a line, it wants you to keep moving in a straight line. So as you're moving in a circular path, let's say that you're right here, well, here's your velocity, here's your direction right there. So inertia makes you want to move this way. But centripetal force will bring you back in the circle. And remember, centripetal force will either be your friction, your tension, or your gravity. So inertia keeps you wanting to move straight. But centripetal force will pull you back in the circle. So as the car moves in that circular path, and you go in to hit the passenger door, well, you want to keep moving straight. The car is going to pull you in a circular path. However, you're still moving straight, so you're going to hit the car door. The car door is going to push back on you and keep you moving in that circular path. This is why the bucket with the water works. If I have a bucket and then I twirl it in a circle, centripetal force helps to hold the bucket or the water in the bucket because inertia is also acting on this. So as the bucket is moving around in the circle, the water is going to want to move in a straight line. However, the water hits the bucket and the bucket hits on it back, so it keeps the water inside of your bucket. That's why this trick works. So when we talk about centrifugal force, it's not a real force. It's a concept, and we need to talk about it, but it's not a real force. Inertia is what helps, inertia is really what ends up, or it keeps your body wanting to move in a straight line. But centripetal force will make it move in the circle instead. Alright, so that's all for this video. I will see you guys next time.